in this question we are given the Lagrangian of the system. We are asked to find its Hamiltonian. So the Hamiltonian, the general formula for the Hamiltonian is H summation q dot p minus L. Now here we have two components, so we can expand this and write. So this is qx dot p plus qy dot py minus L. So qx I can replace with x dot, because our coordinate here, our generalized coordinate is x and y, Cartesian coordinates, so we are replacing it by x and y. Now we can of course compute the conjugate momenta using the formula that it is the partial derivative of the Lagrangian with respect to x dot. So the Lagrangian is there, take its partial derivative with respect to x dot and you get what you get is m x dot plus m y dot. So similarly you have to find for py. So py is of course the partial derivative with respect to y dot. So this is m x dot. So from this we can have a equation for x dot. So x dot is equal to py by m. And y, from this equation we can solve for, we can substitute here in terms of x dot and solve for px. Okay, we want a y dot in terms of px and py. So the point is to, in this Lagrangian, in this equation we are going to substitute x dot and y dot in terms of px and py. So you can find that y dot from these two equations, that y dot is px minus py divided by m. So now just substitute this x dot and y dot in this Hamiltonian equation in terms of px and py. So this is suffix, right? So let me be clear. This is suffix. So when you substitute that, or check that, you get that the Hamiltonian that you get is px py by m minus py the whole square divided by 2m. So this is your answer. So the right option for this question is given by the option C.